Hi everybody, it's time for video number 3, and this is where we're testing critical values to find global extrema. This video is a lot shorter than the last one, so let's just jump right in. So the first thing to do is recall that for global extrema, our candidates for those extrema are, first of all, our critical values, where the derivative equals 0, and where the derivative does not exist. But we also have to throw in the endpoints of the domain that we're given. Okay, so these are all our candidates, our critical values plus the endpoints of the domain. Okay, the test is a little bit different. I'll show you the test when we get to it, but let's just look at an example really quickly. Here's y equals x plus sine x. If I want to find, and I'm given an interval from 0 to 2 pi. All right, so let's find our candidates for global extrema. So I'm going to set my derivative. First, I'm going to calculate my derivative. Oops, let's make that a 2 sine x. X plus 2 sine x. I'm sorry, I miscopied that. The derivative is going to be 1 plus 2 cosine x, and I'll set that equal to 0, and that gives me cosine x equals -1/2. And so if I need to find out where those are, I'm going to look in the unit circle. So cosine x is -1/2 would be like right around here. 1/2 √3 over 2. So this would be 3 pi over 6 plus 1 more would be 4 pi over 6. And then my other spot, I'll use a different color for that one, would be here as well. So this is pi over 6. So I'm going to have 1, 2, 3, 4, 5, 6, 7, 8 pi over 6 for my other critical value. And those simplify down to be 2 pi over 3, and 8 over 6 is 4 pi over 3. So those are my two critical values, and I also have endpoints, which are 0 and 2 pi. So I have 4 possibilities for global extrema. Okay, let's go to the next slide where it's a little cleaner. Two pi over 3. Might as well keep it simplified. And the other one was 4 pi over 3. Yes. And finally 2 pi. Those are my 4 possibilities. Okay. Now, I don't have a calculus test to find my global extremum here. And that's because at the endpoints, the derivative might not be 0, and the derivative might not be does not exist. So there's really no way to use calculus to tell what my largest point is, my largest value is. But we're only looking for the very largest value and the very smallest value. So I'm going to do what I call the 5th grade math test. If you were back in the 5th grade and you had a calculator and you were asked which of these x values gives you the highest y value, you don't know any calculus. All you know how to do is calculate. You would just plug these numbers into your original function and then see what you got, and then pick the one that has the largest output. So that's the test that we want to use when we go for global extrema, absolute extrema, the very largest or very smallest. This doesn't work for local, only for global. So I'm going to plug these in, x and f of x. I'll plug in my 0, my 2 pi over 3, my 4 pi over 3, and my 2 pi. And so this will be 0 plus 2 times sine of 0, which is 0. This one is 0 plus 2 times sine of 2 pi over 3, which is 2 times root 3 over 2. Let me double check that. I'm going to just really quickly use my calculator to double check that I am on the right track. 2 times sine of 2 pi divided by 3. And actually, let me take that 2 out. Yes, 2 times root 3 over 2. 4 pi over 3. I'm going to, let me fix all that. This should not be a 0. This should be a 2 pi over 3. My function is x plus 2 sine x. So I'm plugging into that. Okay. For 4 pi over 3, I'm going to have 4 pi over 3 plus 2 of sine of 4 pi over 3, which is 4 pi over 3, and minus 2 times root 3 over 2. And for 2 pi, I'm going to have 2 pi plus 2 times sine of 2 pi which is 2 pi plus 0. Now, which of these is biggest? Obviously, 0 is not the biggest. Let's just get some calculator estimates. So 2 pi over 3 plus 2 times sine of 2 pi over 3 is about a 3.826. The next one, 4 pi over 3 plus sine of 4 pi over 3 is about a 3.322. And 2 pi is about a 6.283. Okay. So I look at these y values and I see that this is the largest and this is the smallest, and those are my answers. So my final answers here would be that I have a global min of 0 at x equals 0, and I have a global max of 2 pi at x equals 2 pi. That's all there is to these. These are much, much simpler, but let's take a real quick look at the graph. So I have x plus sine, whoops, let me type in here, x plus sine of x, and I want to restrict my domain, so I'm going to say 0 less than or equal to x less than or equal to 2 pi. The curly braces allow me to do that. Let me smudge down here. And where is my graph? How about a positive 2 pi? Ah, that's better. So there's a picture of my graph, and we can see, yeah, there's the lowest point is at 0, 0. There's the highest point at 6.28. It looks like I've got a maximum here somewhere. Okay, and a minimum here somewhere. Those are the two critical values that I found, the 2 pi over 3 and the 4 pi over 3. And that's all for this video. We have one more video, and that's using these in something called L'Hopital's rule. See you there.